Hello, today we'll be doing question 9.42, and this asks us to determine 8 constitutional isomers with the molecular formula of C5H12O, and determine the IUPAC naming for each of those isomers, and determining if the alcohols in them is either primary, secondary, or tertiary. So remember, a constitutional isomer is a molecule with the same molecular formula but differs in their bonding. So right away, I can draw the most simplest one, being 1, 2, 3, 4, 5 carbons, and we have the alcohol that is required. And if you see here, we have 12 protons, 1 oxygen, 5 carbons. So this is one isomer. Now let's draw a second potential isomer. So 1, 2, 3, 4, 5 carbons, but now we'll put the hydroxide on carbon 2. And lastly, we have 1, 2, 3, 4, 5, putting the hydroxide on carbon 3. So these are simplest constitutional isomers that we can draw. Now we need to be a little creative, moving around the position of the carbons. So if I were to draw something that has a parent chain of 4 carbons, so 1, 2, 3, 4, I can add the hydroxide here, but now we need an extra carbon, so I can just arbitrarily place it here on carbon number 3. So using that same logic, I can now reduce the parent chain to 3 carbons, add my hydroxyl group, and then I can add those 2 extra carbons as a 2,2-dimethyl functional group. Alternatively, I can go back to this original 4-carbon design I had, 1, 2, 3, 4, but now add both the extra carbon, number 5 here, as well as my hydroxyl group. Another thing I can do, building off of this one right here, is I can do my parent chain as having 4 carbons as well, 1, 2, 3, 4, adding my hydroxyl, but instead of adding the methyl here, I can add it right in the middle on carbon 2. Lastly, I can switch the positions of these two. So now I have 1, 2, 3, 4. I can add a methyl on carbon 1 and a hydroxyl on carbon 2. So this gives us 8 constitutional isomers. So now let's determine the alcohols are primary, secondary, or tertiary. So here, attached to this carbon is one substituent that is non-hydrogen. So this is obviously a primary carbon. This one over here, we have 2 substituents that are non-protons. So we have a secondary hydroxide here. This third one, we have 2 substituents that are non-protons. So we have secondary as well. Here we have 1 substituent, so this is a primary. Here we also have only 1 substituent, so this is primary. Here, however, we have a 1, 2, 3 substituents attached to the central carbon. So this is tertiary. Here we have 1, it's primary. Here we have 2, secondary. Now for IUPAC naming. So remember, the trick is to identify your parent chain, which is your longest chain, and then identify all the substituents that are attached to your parent chain. So if we start with the very first one has 1, 2, 3, 4, 5 carbons, so that's right away a pentane chain, but we have an alcohol, so I'll change the suffix to ol, and the alcohol is at position 1. Here, same thing, we have 5 carbon parent chain, however, the hydroxide is on carbon 2, so we have 2-pentanol. And remember, you want to name your functional groups such that they land on the lowest number carbon on the parent chain. So if I were to count from the left side going to right, then it would be 4-pentanol. But if I count from the right, I'll be able to draw or represent the structure by saying 2-pentanol. So that's the correct one, something that generates the name with the lowest number substituent. For this third one down here, same thing, we have 5 carbons, but now the hydroxide is on carbon 3, so we have 3-pentanol. Here we see that we have our hydroxide on carbon 1, and then on carbon 4 we have a methyl group. So I'll represent that. I'll write, we have 4 carbons, 1, 2, 3, 4. So our parent chain is a butane. But remember, we have an alcohol, so the suffix changed to -ol, and the alcohol is at carbon 1, leaving us with the methyl group on carbon 3. For this one, we have a propane parent group. The longest chain is 3 carbons. But remember, we have to change the suffix to -ol, and the alcohol lands on carbon number 1. And then we have on carbon 2, 2 methyl groups. So because we have 2 methyl groups, we act as if these substituents are individual and isolated from one another. So we need to say 2 dimethyl 1-propanol. So you need to ensure that you treat these substituents as unique and individual substituents, and they just happen to be the same. So that's why we say dimethyl, but we need to say 2 so it represents that these are unique and individual substituents. For a third one, we identify the longest chain is a butane. Remember, we change the suffix to butanol, and the alcohol exists on the 2nd carbon. But something else also exists on a 2nd carbon, and that is our methyl functional group. So we also say 2-methyl. For this one here, we see that we have a 4-carbon parent chain, so that's a butane. We change the suffix to make a butanol. The alcohol exists on carbon 1, and we have another functional group being a methyl, which exists on carbon 2, so 2-methyl 1-butanol. And for the very last one, our longest chain again is a butane. We change it to butanol. The alcohol exists on carbon 2, and we also have another functional group being a methyl on carbon 3. 3-methyl 2-butanol.